Now, why is that happening? A moment ago, we actually explained that the variable difference, when the value of these variables, it goes out of bounds that the machine can hold, you will see problems like Stack Overflow. Now, in this case, there's not much of a data set problem, but it is the same symptom that you're seeing where the variable, if you look at the variable, the one, Tushar, you got the Stack Overflow. Can you print your W and W next right before it gave you that Stack Overflow? Okay. No.
So Ranga gave his number. Shubham has given his number. Mustafa has given.
Okay. No.
So the one who got Stack Overflow, Tushar, can you print your numbers as well? Yeah, it was 1.13 to the power.
Okay. So yeah, this is what I wanted to get to. So e to power plus 48 and e to power plus 147, right? So it gave you very large numbers. So now the effect you're seeing is on the other end of the spectrum where your numbers got so large and out of hand that your machine cannot even run those. And it's a very simple one, very few lines of code. And I got overflow error where numerical result is out of range. You will get different symptoms, but essentially the main message here is if your learning rate is very large, then you will run into overflow or uninitialized problem. Stack TensorFlow will give its different kind of messages. So learning rate decision is a kind of an art at this point, and there are several techniques and advices out there in the literature as to how to find out the best learning rate for your model and data set. And this is actually tuned to your data set and to your model. These two things affect your learning rate. Okay, so I'm going to wrap it up. Our main message out of this exercise is the numbers can go out of range if you're not careful, either with the data set normalization or your learning rate. What does minima signify? Minima signifies that whatever model you've chosen, the algorithm has done its job to find and give you the parameters, the model parameters W and B. So if you chose a wrong model, for example, in this case, we will see soon that our model was not, linear model is not good enough, won't give us good enough accuracy. Learning algorithm is not going to change that model. It'll only give you the model fit. It gives you the model parameters the best it can. So with that, let's move on. So machine learning solution flow. So far, whatever we have done, we have done our data acquisition, we have discussed our data analysis part, and we have done our model hypothesis, and we have looked at a training algorithm, right? Now we are going to do this for wire resistance. So this is the lab where I will spend a little bit of time and then we will speed up. Oh, somebody's saying they need more time. When do we increase or decrease learning rate? Is it still trial and error or advanced as we have other machine algorithms? Okay, so there is an entire, people have written chapters on that. So I like a couple of strategies. Initially, when I'm starting, I look at my data set and definitely normalize it, especially in EDA, you need that, right? Now, what I would do, I would take the subset of a data set. So if I have samples which have like in millions, I won't take and run with million. I will run with less than 1,000. And because it runs in the 30 seconds, and then I will find out where is the bound of this learning rate. And there are a couple of strategies. One is where you take a mesh, the two ends, and you do binary search on that. And if you have, so learning rate is just one. Now if you use other algorithms like ADAM optimizer, it has 3 parameters which are similar to learning rate. Then you will have to create a kind of a cube and search where do you get the best fit. So essentially, it's either your binary search or your grid search. It's called grid search in the literature. And then there was another very interesting paper Jan LeCun has published back in 2008, whereby he recommends for deep learning specifically, he recommends the random approach within limits to find the hyperparameters. So learning rate is a hyperparameter, and you would see that term being used in the machine learning way too often, more than learning rate. Learning rate is only for certain algorithms. If you change your algorithm, you will have beta 1, beta 2, and depending on algorithm, you will have different uh, nomenclature. So with that, let's go. So
Yeah.
we are
So
going to
everyone,
start.
I've just copied pasted the link in the chat box. That's the so this is the link for the lab. You might just want to click on the link. Yeah. Yeah, Rohit, we can continue.
Okay, I'll wait for a few seconds.
Okay, so
Just
everyone, can you click on the link and just notify us whether you're able to get the labs? Okay. All right.
great.
Yeah. So yeah, everyone was able to get it.
Okay, so everybody else who's sleeping, please wake up. We are going to discover something here, and hopefully you would be part of that discovery.
So I guess nobody's sleeping because they're all glued to me and they're chatting with me. That's pretty interesting.
Great. Okay, so here we would figure out a couple of things, and like I said, this is not the best model that you would come up with, but it's very good for learning because it's just single line, and we are actually discovering so many things with simpler approach. Gradient descent gave very couple of very good messages that people struggle for months, especially beginners, to sort of catch on to. Now with this, I'm going to go over cell by cell and quickly. This is just supporting libraries. The first 3 lines is just to import the data set, and you have NumPy and TensorFlow. And then I'm going to show you some plots. So this is just for that. I'm not going to explain the plotting part. You will understand it on your own. We will just use this part to show how the plots look and how can you derive the meaning out of those plots. So this is the same database that we've been talking about. Same numbers. Oh, I have to run it. Okay, what I'm going to do is, for the sake of speed, I'm going to run all here. So it's connecting and it's going to run, and I'm going to review the results. Otherwise, we would have run cell by cell. Okay, so these are our hyperparameters. I'm putting learning rate 1 here. So this is I have tuned before coming here so that you guys don't run into problems. Training apex. Apex is one sort of terminology used in machine learning. It's nothing but when the data set goes through training one full time, and then it's called apex. In the olden days, apex means like large amount of time, an age sort of. Back in 60s, it used to take days to run these kind of data sets. So very small data sets, it will take days. So they used to call it apex, and there were other algorithms which will run on smaller data sets, and that is called iteration. So iteration and apex are different, and they have specific meaning, especially when you're talking to data scientists. Don't use iteration if you don't mean iteration in machine learning. You'll get confused. I've had that experience few times myself, so I'm very careful now. Epoch means when your data set goes through training once, that's one epoch. Now you might do several iterations because you might divide this data set into, let's say, 10 different batches, and that's called mini batching. So iteration is one iteration of the batch. When the entire data set is done through the training, it's called epoch. So with that, I guess we did that. Okay.